Hello, everyone. Welcome back to the DBMS revision series. So, SPPU MCA engineering students, let's get right into it. आज हम DBMS का एक modern or industry important topic समझेंगे. We're diving deep into Unit 5 today, which is all about data distribution strategies. Literally, whether you're just aiming to score top marks in your exams or you genuinely want to understand how massive tech companies actually manage their data, ये explainer आपके लिए perfect है.
Before we get bogged down in heavy textbook definitions, I really want you to think about something. Why does WhatsApp never crash globally? Think about it. Billions of messages are sent every single day, videos are uploaded constantly, yet the system is almost always up and running perfectly, right? Well, the secret behind this flawless performance doesn't lie in one single supercomputer. Nope, it lies entirely in data distribution. And by the end of this session, you're going to understand exactly how they pulled it off. Let's look at our roadmap for today. First, intro to data distribution, then fragmentation, replication, allocation, an exam point of view section, and finally, a quick revision summary.
All right, Section 1, Intro to Data Distribution.
ध्यान से समझना, please understand this carefully. Data distribution is the process of spreading a single database across multiple physical locations or servers. Imagine a traditional database as a giant, heavy book kept in one single library. If everyone wants to read it at the exact same time, there's going to be a huge line, right? So data distribution means we take that database and we spread it out across different cities, different servers or nodes, so it's not all stuck in one single bottleneck.
But why is this technology needed? Zarurat kya hai? Well, there are three massive reasons for this. First is better performance. When data is spread out, the load on a single server is heavily reduced, making everything much, much faster. Second is high reliability. If a server in one city loses power, your system doesn't just shut down because the data is distributed elsewhere. And third is easy scalability. Think of a real-world application like cloud storage. Services like Google Drive handle massive amounts of user data effortlessly because they just keep adding more distributed servers as they grow. It's brilliant.
Moving on to Section 2, Fragmentation.
Now pay really close attention here, as this is a guaranteed exam question. By definition, fragmentation is the process of breaking a single database into smaller, logical parts called fragments. Let me give you a very simple real-life analogy. Imagine you order a massive, family-sized pizza. You obviously can't eat the whole thing in a single bite. What do? You cut it into smaller slices, so you and your friends can easily take what you like. Fragmentation is exactly the same concept. We are slicing a massive database table into manageable, bite-sized pieces.
Now let's look at how we actually slice that data. In your exams, you'll definitely be asked to compare the two main types. We have horizontal fragmentation, which means we are splitting the rows of a table. And we have vertical fragmentation, where we are splitting the columns of a table. Let's see exactly how massive tech companies use these two different slicing methods in the real world.
Let's start with horizontal fragmentation. Think about a giant e-commerce application like Amazon. They have millions of customers across India. So instead of keeping all Indian customers in one massive clunky table, they use horizontal fragmentation by splitting the rows by city. They literally put all Mumbai users in one fragment and all Delhi users in another. The result? When a Mumbai user searches for a product, the system only searches the local Mumbai fragment. It makes the entire search process incredibly fast.
Okay, now let's look at vertical fragmentation. A great real-world application for this is banking systems. In a bank, a customer's record obviously has many columns. Banks will use vertical fragmentation to split the table by data type. For example, they'll take the highly sensitive columns like your personal info, passwords, and PINs and store them in a highly secure fragment. Meanwhile, your everyday transaction history columns are stored in a totally different fragment that gets accessed more frequently. It's just a perfect way to balance security and speed.
Next up, Section 3, Replication.
Replication is the process of creating and maintaining exact copies of database fragments at multiple sites. Think back to your college days for a second. Just before an exam, you don't just rely on one single notebook, right? You make photocopies of that one topper friend's notes and share them around so that literally everyone in the class has a backup. Replication is exactly that. We are making photocopies of our database fragments and spreading them around the network. Let's look at real-world replication to make it crystal clear. When a reel goes viral on Instagram, they don't just leave that video file on one single server. No way. They replicate it. They make exact copies of that viral post on multiple global servers so it loads instantly for everyone, everywhere. Similarly, Google Drive automatically creates backups of your files across different data centers. The massive benefit here? Zero data loss. Even if a whole building of servers catches fire, your data is completely safe. However, in engineering, you know everything comes with a cost. You need to know these replication trade-offs. The advantages are pretty clear. High availability, meaning your data is always there when you need it. And faster local reads, because you can read from a copy that is geographically closest to you. But the disadvantages? Well, high storage cost. Storing 3 copies of data means paying for 3 times the hard drives. Also, slower global updates. If you change a profile picture, the system has to update every single copy across the globe, which obviously takes a little time.
Let's jump to Section 4, Allocation.
Allocation is defined as the process of deciding exactly which node or server will store each data fragment or replica. Going back to our college notes analogy, once you have the photocopies, you have to intelligently decide which hostile block gets which copy based on who actually needs them the most. You can't just throw them around randomly. So allocation is basically the smart, strategic distribution of our data pieces.
To understand this perfectly, let's look at the Netflix allocation strategy. Netflix used to have a huge problem with video buffering. Their solution? Highly intelligent allocation. They analyzed user habits and decided to place regional movies directly on local regional servers. They allocated South Indian movie fragments heavily to servers in the South and Bollywood movies to servers in Mumbai. The result is instant streaming without buffering, simply because the data was allocated exactly where the users were requesting it from.
All right, let's talk about Section 5, exam point of view. If you get a long-form question on distributed databases, I highly recommend drawing this exact table. It shows the examiner you have a clear, structured understanding. Under advantages, list highly reliable, easily scalable, and faster data access. Under disadvantages, make sure to list that they are complex to manage, they require expensive infrastructure, and introduce potential security risks since the data is constantly traveling across multiple locations. Presenting your answer this cleanly is absolutely guaranteed to impress the evaluator.
Here are some quick top tips to score full marks in Unit 5. First, always draw basic block diagrams when explaining horizontal and vertical fragmentation. Visuals matter so much. Second, use the real-world examples we just discussed, like Netflix and Amazon. It shows you actually understand the industry application, not just rote learning. Finally, underline key terms in your definitions, like logical parts for fragmentation and exact copies for replication. The crucial point here is to make the examiner's job super easy by highlighting your knowledge.
Let's wrap it up with Section 6, Quick Revision Summary.
If you ever need to summarize data distribution in your head, just remember this chronological 3-step process. Step 1 is fragmentation. You break the massive data into smaller logical parts. Step 2 is replication. You make reliable backup copies of those parts. And step 3 is allocation. You intelligently store those copies at the most optimal geographical locations. Boom! That is the entire secret to modern database management in just 3 simple lines. I want to leave you with one final thought to really make sure this sticks. If a Google Drive server crashes tomorrow, where will your personal data come from? Well, now you know the answer. It will smoothly load from an exact replica that was intelligently allocated to a secondary server hundreds of miles away. The magic of the cloud is literally just exceptionally good data distribution.
I really hope ये explainer आप सबके लिए helpful रहा हो. SPPU MC exams के लिए best of luck, अच्छे से पढ़ाई करना. अगर आज की क्लास helpful लगी हो तो like, share and subscribe जरूर करना. Good luck with your revision